Hi, welcome back to this tutorial series on Introduction to Matlab. In the last tutorial, I discussed about how to create matrices and vectors in the Matlab. We also saw how we can use special matrices such as zeros and ones to create a matrices with special entries of zeros and 1. In this tutorial, I am going to discuss about how many operations or different operations that can be performed on the vectors and matrices. Let's get started. So first, let's see what kind of operations we can do on the matrices. So these are the different operations that can be done on the matrices, such as addition, subtraction. We can also multiply the matrices by a scalar quantity. We can also multiply two different matrices. We can find out transpose of matrix, inverse of matrices, determinant of a matrix, and adjoint of matrices. So these are the different main operations that we can perform on the matrices. There might be some other operations, but these are some of the very important that we are going to use very frequently. So let's look at the first options, that says addition of two matrices. To do that, let's first look at two matrices. The matrix A, which contains the elements 10, 20, 45, 56, 78 and 89, and which is actually of order 3 cross 2. So that means it has 3 rows. So this one is the first row, this one is the second row, and third row, and it has 2 columns. So this is first and this is second column. So we have 3 cross 2 matrix. Similarly, we have another matrix B, which is again of same order 3 cross 2. That means we can perform additions or subtractions on the matrices which are of same order. So let's see how we can do that. So let's suppose I want to add these two matrices. So then I'm going to add A and B. Then I will store this value into a new variable that I am defining over here is capital C. So this C will be my new matrix, which is basically the addition of two matrices A and B. So if I add these two matrices, then these individual elements, that means the number 10 will be added to the 15, then 20 will be added to the 6. Like that we do the additions, then the answer is going to be 25, 26, 55, 58 and so on, and the order of matrix is going to be same as the previous matrices A and B. So let's see how we can do the same in the Matlab. So I'm going to move to the command window and we will start writing our command into the command window to generate the matrices A and B. So I'm going to name it a variable A, which is capital A. You can use any variable you want. I'm sticking to the capital alphabet with the matrices, and small alphabet I'm going to use for the vectors. So let's create a matrix A, which is basically has 2 columns. So I'm going to write first row, and which contains basically 2 columns. So I will supply these two numbers 10 and 20. So by writing these two numbers, that mean we are going to create 2 columns. This ends now the first row. Then I'm going to move to the second row and I will start writing my number that is available in the second row. So 56, then going to be 78 and 89. Make sure you separate these different rows by semicolon, because whenever we move to the next row we have to use this semicolon. So if I press an enter key, you will see a matrix A is created, which is basically having 3 rows and 2 columns. Similarly, we can generate our second matrix, which basically contains 15, 6. Then I'm going to move to the second row by using this semicolon over here, then 10 and 2. And similarly, the third row is containing 13 and 5. If I press an enter key, then matrix P will get created. Now we have to perform the addition operation on these two matrices that we created. Let's store this addition into a new variable C. Then I'm going to use this equal to sign, which basically means the assign operator, and what I'm going to assign it is the addition of these two matrices. So I'm going to use A, then plus for addition, and then I'm going to supply this B matrix, and I press an enter key. So I will get this a new matrix C, which is basically the addition of these two matrices. Similarly, we can perform the subtraction. So let's suppose I want to subtract matrix C and matrix B, let's suppose. So then the result of this I am going to store into this new variable D. If I press an enter key, you will see that we get this D matrix. If you look clearly, this D matrix and A matrix is basically same, because C was basically the addition of these two matrices. If I remove the B from it, then I'm going to retrieve back the matrix A, which I'm going to store into this D new variable. Right. One more thing you can do is, we have defined the variable A over here, and if you want to access this variable A later onward, so you can just simply write A over here and press an enter key. So the same variable that we created earlier will now be again displayed into this command window. The next option over this is multiplication by a scalar quantity. So what that actually means, let's create a matrix M, let's suppose name it as M, and then what I'm going to do is I'm going to multiply it with a scalar quantity. Scalar quantity means I'm going to use any constant or floating point number, that means decimal points, and I'm going to multiply it with any matrix. So let's suppose multiply 5 with the matrix A. So I'm taking matrix A and then I'm multiplying it with this 5 numeric value, and this symbol over here represents that we are going to multiply two things. So if I press an enter key, you will see that this 10 times 5 is 50, then 20 times 5 is 100, 45 into 5 225. Similarly, the different number is being multiplied with this 5. So this means that we can multiply it by scalar in this way. Next option that we have is the matrix multiplication. So for matrix multiplication, let's suppose we have these two matrices. The first one is this 2 5 8 10, which is matrix E, which is basically of 2 cross 2, and another one matrix that we have here is F matrix, which basically contains these elements 6 3 5 50 20 and 4. And if you look over here, then the order of this matrix is basically 2 cross 3. That means it is having 2 rows and 3 columns. Now whenever we want to multiply any two different matrices, then there is one condition to multiply these matrices. That means number of columns in E. If we want to multiply E with the F, first we write E and then we write F, then the condition is the number of columns in E. That means it basically has two columns. So this is first one and this one is the another column. It must matches with the number of rows in F. So this is F, so it should contain 2 rows because it contains 2 columns. So let's start writing over here. So first I'm going to define the matrix E, which contains the element, remember it is 2 cross 2, so that means it has 2 rows and 2 columns. So we supply 2 numbers in the first row, that means it is going to give us the 2 columns. Next we move to the next row and then I'm going to supply the another 2 numbers. So it's now a 2 cross 2 matrix. Similarly, I'm going to use F. I'm going to create F, which basically contains 3 rows, 2 rows and 3 columns. So 6, 3 and 5. So it has basically 3 columns. So I'm going to supply these 3 numbers in the first row, then I'm going to move to the second row using this semicolon, and then I'm going to supply the other 3 numbers, that is 50, 20 and 4. Next I'm going to close this bracket and I'm going to press an enter key. So now Matlab has a command to know the size of these matrices. So let's call this function size E. This function you can access by using help elmat that we did earlier, like that. So if I press help elmat, then it is going to give me all the functions that is available that can be operated on the matrices. So if you go here, you will see this basic array information. There you have this size. It says size of an array. So the order of matrices we can access through this size function. So I'm going to supply this E matrix to it, and then I'm going to close this using index bracket because we are calling the function. So you will see now, because we have not supplied any variable, so it's going to be stored into the default variable. So it says 2 and 2. So the first element over here means we have 2 rows, and the second element represents how many columns we have. So basically it is 2 cross 2 matrix. Similarly, I can access for F, and you will see it is basically having 2 rows, and if you see F over here, so it is basically having 2 rows and 3 columns. So the same result is shown here, 2 rows and 3 columns. So size basically is used to know the size of an array. That basically means the matrix or vector. So fine, let's multiply these two matrices. Let's call this new matrix as a Z. Then I'm going to supply the first one is E because we have put it the condition on E and F. So first we have to supply E because number of columns in E must be equal to number of rows in F. So for multiplication I'm going to use this, and then I'm going to supply F. Now I'm going to press an enter key. You will see this is my Z. If you see the calculation here, 262, 106, 30, 548, 124 and 80, the same result is displayed over here, right? So this how we can multiply, addition and subtract and do different operations. Next one operation is the transpose of a matrix. So transpose basically means we changes rows into columns and columns into the rows. So that what does that means? So let's enter F over here to display what F contains. So F is basically this 6, 3, 5, 50, 20 and 4, right? Now what I'm going to do is I'm going to use transpose. So if you want to find out the transpose of a matrix, so you can just simply go here, and if you write this trans over here and you press a tab key on the keyboard, then it is going to display all the functions available. So I'm going to use this transpose, and then I'm going to supply this matrix F, and if I press an enter key, then it is going to change rows into columns and columns into the rows. So basically these elements 6, 3, 5 was arranged in this first row. Now they are displayed in this column now. So this is use of the transpose. You can simply calculate transpose by pressing F and then use this comma over here at the top. So this is basically apostrophe, so you can use this apostrophe or this comma at the top. If I press an enter key now, it's going to transform that F matrix into this new matrix, which is basically the transpose of F matrix. We can also find out inverse of a matrix. So the next option over here is the inverse of a matrix. So to find out the inverse of a matrix, we have to define a square matrix, which basically means we should have equal number of rows and columns. So let's start writing any matrix H, for which I want to I'm going to declare first the matrix first. So 1, 2, 3, then let's suppose 45, 56, you can supply any number, and then 10, 20 and 30. If I press an enter key and now call size of H, and you will see that we have equal number of rows. So first one is the rows and second one is the columns. So we have 3 cross 3, that means it is a square matrix. Now we can just simply call the function that is built into the Matlab is the inverse. For inverse we are going to use this inv command, and then I'm going to use this index bracket, and then I'm going to supply the matrix to it. So if I press an enter key, it says matrix warning, matrix is close to singular or badly scaled, result may be inaccurate. So this warning comes in because this particular matrix that we have created here, 1, 2, 3, 45, 56, 12, 10, 20 and 30 is a singular matrix. So basically what does that means is singular matrix are the matrices whose determinant is actually 0. So if A is any matrix and its determinant is 0, then we say it is a singular matrix. That's why Matlab throws a warning over here which says that matrix is close to singular or badly scaled, result may be inaccurate. So let's define some other matrix. So I'm going to create 1, 2, 3 and then 4, 5 and 6, and then just write 7, 8 and 10. Okay, that would work. So let's press an enter key, and then I'm going to call inverse of these functions, and you will see now we get the result that is basically the inverse of this matrix H. Right, so that warning comes in because we have determinant of that particular matrix to be 0. So that's why that warning coming in. Okay, so next option is determinant. So we can also find determinant of this matrix H. So for that what we are going to do is I'm going to use that command, and then I'm going to use H. I'm going to supply this H. So it's going to calculate the determinant of H. So you will see the determinant of this matrix is -3. Right. and the last one option over here is adjoint. Okay, so we can calculate the adjoint. So let's name it J, and then I'm going to call the function adjoint, which is built into the MATLAB. So we just have to write adjoint, then I'm going to supply H matrix to it, and then I'm going to press an enter key, and it will give me the adjoint. So this over here, J is now adjoint of the matrix H. And if you remember the linear algebra, we can find out the inverse. Let's name it I or something, I don't know. So let's name it some matrix K, which in which I'm going to store the value of inverse. So we can calculate the inverse by using this adjoint J and dividing it with determinant of this particular matrix. If I press an enter key, you will see the same result that we calculated earlier. So what I'm going to do is let's call inverse H and match this. So this answer over here, is same. So we can just simply call, this is built-in functions which actually do the same operations, calculate adjoint and then divide by determinant. We can do that way, or we can just simply call this built-in functions to calculate the inverse of matrix, any matrix, whatever you want. So if you know the one of the property of matrices, if you multiply a matrix with its inverse, then it is going to be an identity matrix. So if I just simply multiply H, which is main matrix, and K is inverse of that matrix, so if I multiply H with a K, you will get an identity matrix. One thing you will notice over here, that the result is not actual integers. It should be 1 1 1 in the main diagram and all other should be 0, but it's showing the number in the 1.00. that means it's showing the number in the decimal points. So MATLAB basically stores a number as a floating point number, and arithmetic operations, whatever MATLAB is doing, are sensitive to small difference between the actual value and its floating point representations. So we can change this display and look, right now it is showing up to 4 decimal place. We can also set it to a large decimal place. So for that we are going to use this command over here, format long. Okay, one more trick over here is, if you press an upward arrow key, up or down arrow key, you can access whatever previous command you have executed. That means they are stored in the history, and you can access that history by using this upward arrow key on the keyboard. And if I press an enter key, you will see that I, which is identity matrix, is actually having these floating point numbers and with a large number of decimal places. And you will see that there is some digits over there, like in this 1.000 there is a 4, and then over here is 25, and so it's not exactly 1 or it's not exactly 0, it is some approximation result over there, right? So, and MATLAB is displaying it because we have formatted that numbers, and we are just trying to display it up to 4 decimal place. So we can reset it by using this format sort, and if you reset it by using format sort, then we are going back to this 4 decimal places. So this is all about today's tutorial, and we saw only different operations that can be performed on the matrices. Next tutorial I'm going to discuss about how many operations we can do on the vectors, but vectors are basically just the special case of the matrices. So we can do all type of operations like addition, subtractions, multiplication by a scalar, like that operations on the vectors as well. But we will also see how we can create vectors in different way, using like linspace or log space, or using something called colon operator. So I hope you like this tutorial. Please like, share and subscribe. I will see you in the next tutorial. Thank you very much.